Alright, hello. Welcome to a new video. Today we're doing this problem called count good nodes in binary tree. I did solve this 2 weeks from when I'm gonna post this. 2 weeks from the date of when this is gonna be posted. I saw this 2 weeks ago. But I think that was one of my first problems that I've done with binary tree. But now since I've studied and learned from doing more problems with binary trees, and kind of grasp the patterns of how to kind of solve these problems where we're traversing the tree. We want to return a result depending on what our conditions are for a result. So yeah, I feel really confident about this, just solving it like right now. It's pretty easy in my opinion, but who knows, maybe I'll mess up during this video, and then yeah, we'll see. Yeah, let's go solve this. Alright, so given a binary tree root, a node x in a tree, in the tree named good, is named good if the path from root to x, there are no nodes with a value greater than x. Okay, so return the number of good nodes in the binary tree. So that's pretty simple. So our input is just the root of bt, and then our output, our return value, is going to be, I'm gonna guess int of good nodes in tree. And to note that, what is a good node? Well, glad you asked, because a good node, it says in the problem, is when a node x in a tree is named good if the path from root to x, there are no nodes with a value greater than x. So a good node is when cur max in path is less than x dot val. Yeah, so basically good node is equal to max in path, max val and cur path. So yeah, that's what a good node is. That makes sense to me. If you don't, then we'll go through an example to kind of showcase what really is a good node. So yeah, that's all the notes that I have so far. And for some questions, I guess the question is, so the question is, what is the min value of node in BT? That's a good question because we want to know where to start off at, because we don't know if we can set our current max to be 0, right? Because we're gonna start the root, right? And then if we set our current max to 0, and let's say our node is like -1, then we won't count our first node to be a good node, even though it should be a good node because it's just the start of like a path, right? So let's go scroll down, and it says that the node value is between negative infinity to positive infinity. So negative infinity, right? So that's a good question to ask. And then I didn't really think about it, but the size, what is the size, min size of the BT? Then the interviewer would say 1. That's the min size. Alright, so that's enough for questions and notes, and we know our input and output, so water break. So let's go ahead and go through an example. Let me sit up. Let's go on a Jamboard. Alright, so let's see. Alright, so I'm just gonna copy this example. I think it's pretty good. So alright, so let's say we have this example, -3, then oops, it's 3, 1, 3, and then it's 415, right? And they point like this. The circles too. All right, so let's go through this example. So we're gonna start off from the top of the binary tree, so basically the root. And we know we're gonna have a current max for the paths we want to take from the root. So let's see. So our current max is going to be 3 because that's where we start off. And then from the root, we can go left and right? So we're going to have 2 different paths. We're going to have current max here, starting from the root. And then we arrive at, let's say we start from the left. I mean we go from the left, or go to the left. And so we hit this 1. Our current max is 3. Oh yeah, actually, I need to actually count the good nodes, so check. So current max is 3, and the node value is 1, and 1 is less than 3. So I mean 1 is not more than 3, so 1 is not a good node, right? And then we go left. I mean we go right. Nothing's there, so we don't really care about that. Then we go left. We can see that our good node, we can see that the value is equal to our good node. But that's actually a good question. I know it says that it is a good node, but let me see. Okay, so I'm guessing it doesn't really say, but I guess a good node could also be, let's take that note. So a good node could also equal to max. Okay, that's a good thing to know. Even though, like, they don't say it here, but it's implied because they count this 3 as a good node. So this is a good node. So yeah, so good node's current max still 3. So there is like, yeah, that's a good node. And then now we're done with the left, because on the left it goes to null, from left and right. We stop there, and now we go to the right. Is that first search we're doing? What are we doing? We're doing pre-order, I think. Yeah, I'm pretty sure it's pre-order. But anyways, so then we go to the right. No, is it in order? I think it's in order. Yes, yeah, I think it's in order. But anyway, so we go to the right, and then we see this 4. My current max on the right path is just my current max is 3, and so 4 is greater than 3. So now our current max is 4, and now 4 is now a good node. So check. That's a reverse check, but oh, I noticed that these look the same, but it's just a different color. But anyways, so that's cool. So now we count 4 as a good node. So now let's go through our left and right. So this is where it's gonna get a little bit tricky. Well, not really tricky. It's just gonna get interesting a little. So since 4 has 2 children left on left and right, we're gonna go left and right with 2 other current maxes, because these are still paths from the root, right? And now let's go left. 1 is not greater than 4, so this node is not a good node because it's less than 4, which is our current max. And now we go left and right. There's nothing there, so we just do nothing, I guess. And now let's go to our right. 5 is greater than our current max, which is 4. So 5 is a good node, so check that. And now, once we get that, let's go left and right. Again, nothing there, so we just stop. And so if we count all the check marks, there is 4. So there is 4 good nodes. Cool. So that's kind of an example. Yeah, that is a good example. So yeah, that is a good example. So I kind of want to do one example because I was just thinking about it right now. So let's just say, wait, let me take note. Oh, the min size is 1, so never mind. I was gonna do an example where we receive like an empty binary tree, but anyways, it doesn't really matter now. So we went through some examples. We know our input and output. We took some notes, asked some questions, so we kind of do understand the problem a lot. So let's go ahead and kind of match what we can use to solve this problem. Match. All right, well, we're definitely going to use that for search. But what are we going to use? We're obviously going to take in the node we're using. And then we want to take in the current max that we have right now. That is how we're going to receive the previous. Yeah, that's how we're going to receive the previous node. So the previous node's current max, basically, of the path. So you know how I did like, this is 3 is current max, but then we changed it to 4. But the only way we changed it to 4 is because we compared 3 and 4 as our current max. I mean 4 and 3 being our current max, right? So yeah, we're going to take current max. And then we're just going to use like just going to use max, the max function thing, max method, whatever it's called. And then we can also have a global variable. I know there's a way to solve it without using a global variable, but to me this was my intuition. I only know that there's a way to solve it without a global variable. Because I didn't watch, but I looked over, because you know how LeetCode, if you solve it, they kind of show you the solution. I kind of saw it for a second, so yeah, so I just deleted it. But yeah, I'm gonna use a global variable in this case. It's just easier and more intuitive for me. But you can use like a variable inside each node called, yeah, that like counts the good nodes, and then like it goes down, and then you just add the left and right, and then it goes back up to the root. Then you return the value from the root, from the initial call. So anyways, so we're going to use a global variable. That's pretty much it. DFS on left and right. Get the max. Yeah, so let's just go ahead and do it. Let's go ahead and plan. Alright, so first off, I want to initialize global var result. So I'm going to say the res is equal to 0. And I know that the min value is going to be negative infinity. So I'm just going to say that k value x is equal to like 10 to the 20th. 10 to the 20th. I'm going to make that negative. Oh no, let's name it negative infinity. Right. And then I'm going to create a function. So DFS. Let's take in node and cur max. But before that, I kind of want to so when we run this code, I want to call DFS with the root, and then I want to give it the argument of the root and negative infinity. So just that, I guess. Wait, actually, wait. Yeah, this makes sense. Name it inf, and then just do negative inf. Okay, and then we're going to return res, right? Because we're going to run through this function either way. But anyways, I feel like I should have done some pseudocode in here first, then wrote this, because it just makes more sense. But anyways, that's for another time. So what do we want to do in our depth first search function? Well, we kind of already know what to do. We kind of did it here. So we want to basically, when we started off, right, we kind of compare, well, we kind of know that the root is always going to be the max when we start. But other than that, let's just go ahead and make our base case. So if not, so if node is null, then just return, just don't do anything. Right, or we can just say stop. It makes more sense too. if I made a coding language, programming language, this would be like how I would do it. Just stop. Just have like return, stop. I don't know, because continue is cool too and break. But anyways, so if node is null, then stop. Otherwise, we're going to compare. If not base case, then compare if cur node is more than cur max. So we can say cur max. Oh wait, yeah, cur max is going to equal to node.val or cur max. Yeah. So if not the base case, we're gonna get that. But I don't know, I think it's better coded if it's like, because we're gonna change the value anyway, right? We're gonna increment anyways, right? So we're gonna increment the results variable. So if, oh yeah, we gotta actually reference global var res. So we gotta say non-local res. Yeah, I'm just gonna delete this. Even though we can use the max function, I think it's just better if we just like compare it once, right? So if node that val more than cur max, then res plus plus, and then cur max is equal to that val. Yeah. Then if it doesn't satisfy this if statement condition, then we're just going to not run it anyways, and then we're going to go to our left and right. So dfs node.left with cur max, whether it's updated or not doesn't matter, and then node.right cur max, right? And then we just do a recursion until they all hit the null node, and then where we stop. And then once all this is done running, from this initial call, we're just going to return res. So yeah, so this should work. Let's go ahead and kind of copy and paste our plan in LeetCode so we can get started on coding. All right, cool. So first things first, in our plan, we want to initialize our global variable and set up our negative infinity. So res is equal to 0 for now, and then infinity is equal to 10 to the power 20, and then we want to create our depth first search function. So dfs, define dfs, and we're going to take in a node and then our current max. Let's name it max. Max, that's fine. And then we got to make our base case, right? So base case. So if not node, then just return. And then if it doesn't, oh, we also got a reference our global variable. So non-local res, because it's non-local, it's global. And then we got to go through, if it goes through the base case, then we gotta do what we gotta do, right? So if it doesn't go through a base case, then we have to compare if the cur node value is more than the cur max. So if it's the case that if node.val more than max val, then what we're going to do, okay, I'm just curious like why it's like this. Maybe, I don't know. I think it's fine. I'll also name it cur max because I just want to be safe with it. Yeah, okay. I don't know, just the color just bothered me because it's the same color of the function names. So if node.val is more than the current max, then we're going to say that yes, this node is a good node, so we're going to increment our result by 1. And then we're going to make this, we're going to make the cur max equal to the node value right now, node.val, so we can pass it on to the other nodes, since we want to save the cur max starting from the root to the other paths, right? So we're going to call dfs on the left and right. the current max. And then yeah, and then we're going to when we call the good nodes function, we're going to call the fs starting from the root with negative infinity. And then we're going to return the result once the initial call goes through recursion, all that stuff. This should work, hopefully. Wrong answer. I'm at a 1 off for some reason. Why is it 1 off? Oh, I forgot about the case where, it's not a case, but I took some notes where the good node could also equal to the max. So I think this is the case because I see 2 3s in this one and then 2 3s in here as well. So I'm pretty sure it's that case. Yeah. Okay, cool. So run, pass, submit, pass. Cool. So yeah, for time complexity, it is O of n because we go through every node once. For space, we're using O of 1 extra space. We're just using res to hold the result of our problem, and then infinity. So yeah, that's pretty much it.